Perfect. So, first on today's agenda is Andrea and Tara.
Hi, Tara's not here yet. Should we
Okay.
start or I can go
Yeah, we
second?
can we can just follow up when I see her on the attendees list. No
Okay,
problem.
thank you.
Yeah, so
Oh,
Kevin, do you want to go next?
Uh, yeah, that sounds good. I need to share, and I'll try and be quick since we have a packed agenda. I have a couple slides to go through. Kind of. Sorry, can someone give me share access?
Yuki, if you're able to do that.
Yeah, sure. Just a second. Okay. You should you should access to the
Yeah,
presentation.
thank you. Give me a sec. Yeah, can you all see my screen?
Yeah.
All right. So I think there's a lot of things going on in the Kubernetes community right now, especially around the workload aware scheduling. And so I kind of wanted to give an update about like what's going on in 1.37. And this week I've also was kind of working on some proof of concepts in job set and in queue for the pod group integration about how the integration could start. So I'll try and be quick. For those that are not aware, basically workload aware scheduling, we're trying to go beyond pod by pod scheduling and have kind of a like pod groups basically. There are really three APIs that are being introduced. Workload and pod group were introduced, I think, in 1.36 or maybe 1.35. I think 1.35 is when we started this. Uh, a workload is kind of a static definition. There's no status. It's kind of what controllers are going to read to create pod groups, and pod groups are a runtime object. Composite pod group is a new one that's going in 1.37. This was introduced from really the serving community, and also JobSet has use for this, where there's kind of this idea of nested gangs. Like you might have leader and worker need to be scheduled together, but they can be preempted separately. And there kind of need to be some kind of hierarchy of gangs, and that's kind of I think the API that's being introduced is especially for disaggregated leader worker set and leader worker set. They are heavily wanting to use this API. Uh, yeah, so just basically the idea was is you have a pod group and you can specify a min count, and then it kind of matches with your job, and you have a scheduling group which links to the pod group, and this is kind of what tells the scheduler that I have 1,000 pods that need to be scheduled together. If I can't place them, I won't place any of the pods. So this is kind of effectively the gang scheduling. Uh, Now, workload aware scheduling is not just gang scheduling. Right now, there are four separate features. There's topology awareness, disruption, uh, DRA pod groups, and gang scheduling. So pod group has all of these built in the API, and then the surface area for controllers to integrate is just by specifying in the pod spec what if they're part of a pod group. So a lot of the API decisions go into the creation of the workload in the pod group. Why does that matter? Kind of what we're finding is like what we know we don't want is users having to create their own workloads and pod groups because these APIs will be changing. We expect more features are going to be added over time. And generally, every controller has a way different approach on how they want to handle lifecycle. So one of the ideas, this is kind of what started in 1.37, is to sort of provide a consistent API for what we call true workload authors. This is just because there's a workload controller, and we also call workloads job set. So true workload is just means the actual like thing that users submit. So job set, Kubernetes, leader worker set, and generally what we want to happen over time is that these true workload controllers are handling the lifecycle of pod groups and the workloads. Users are able to specify gang scheduling, disruption, and DRA, resource claims, and topology awareness in their workloads. And we kind of expect really the ecosystem will, or the scheduler will react to that. And one of the things that was introduced in 1.37 is this concept of a builder library to kind of allow people to start how to build these pod groups and workloads without having to worry about the API changing too much, and provide more of like a future-proof integration point. So the first, what's going on in 1.37, or sorry, in 1.36, I wanted to kind of show what integration do we have with Q right now. This actually happens for free because in 1.36, when you have an alpha, when the feature gate for workload with jobs enabled, you actually will have index jobs will create pod groups and workloads by default, and they will just assume that I think the parallelism, the minimum of the parallelism and completions is the amount that you want your gang to be. This is not what we want to do for production. This was kind of to prove out pod group and workload lifecycle and figure out the integration for a workload. But in 1.37, we will do a lot more work around here. But what I wanted to show on the left is kind of what happens with queue. So, when you create a job, the scheduler on the right is a pod group, which says, the scheduler knows I need to place 3 jobs at once, and then queue reads the workload, the job spec, and knows that I have 3 pods that are going to be emitted. So the good news is this is actually exactly what we want. We want the queue's workload to kind of match the scheduling pod group. If they don't, it really won't be a great time because the scheduler can place things very different than what the queue thinks. So in 1.37, what we are kind of doing, we are going to add an API into the job spec. So this is this concept of a scheduling API, which provides a policy, which is basically telling you whether or not you want gang or not. Constraints, so this is topology awareness. Sorry, someone asking a question? Okay. Disruption, so basically disruption all or nothing. So preemptions happen pod by pod, or they happen as a gang. And then the last one is resource claims that allow all the pod groups to share the same resource claim. This is becoming more and more common for GP200, and because they have compute domains and IMEX channels which span multiple nodes, so we want multiple pods to actually share the same resource claim. So this is work that's still ongoing in 1.37. I think we're hoping this will land as alpha. So next thing I wanted to show is kind of a plan we're having for job set. So the idea is I'm kind of taking this API and iterating on it by using the 1.37 APIs right now in my branch. So for job set, there's this idea like at a top level, you can specify a gang, and the user doesn't need to say how many pods they actually want. You can just kind of have a shorthand for saying, I want this thing gang scheduled. So this would actually create a pod, or create a pod group with 65 pods that need to be placed all together. So the driver and the worker are all placed as one. The next one is, it kind of gets more complicated because with job set, we have replicated jobs. So we have the driver and the workers, and we know that we kind of actually want them scheduled as 2 separate gangs. So you have the driver kind of should be placed together, and then the workers need to be placed as a separate gang. And then you kind of want the workers to be on the same rack. And we also want the workers to be disrupted altogether. And so this is kind of the thing we're trying to think through for how do you represent this with workload aware scheduling, because there's all these different features that all kind of have to work together. And then, the last one is dynamic resource allocation pod groups. So the idea that you kind of have I think this is 8 of your pods all sharing the same resource claim. So this is the IMEX channel. And this allows you to, basically use all your pods share the same IMEX channel. And also we have kind of topology awareness built in for the workers. So basically the work is in flight for the four, at least the four controllers I know of right now: Kubernetes, job set, leader worker set, and job are all kind of have active designs and implementations going on in PR land right now to kind of we're trying to gravitate towards using the workload builder API and the scheduling components, so we all kind of have a similar surface area for an integration point. So basically, I've been thinking about kind of for Q, what does this mean? Generally, I think that once the true workload controllers have the scheduling API, I actually think it would make sense if Q should respect that and actually learn how to translate that into its own Q workload. And yeah, and so basically the goal is we want pod groups and the queue workload to kind of be the same admission, basically be the same. Otherwise, I don't expect things to work all that well. Now, the other thing I'm talking about, at the workload level, everybody's going to have, or my hope is everyone has these APIs. So then what do we do about the bare pod integration? That's kind of what I want to talk a little bit about. And then I'll give a demo of the job set and the pod group integration and how that works. So for those who don't know, pod groups, we have annotations for the pod integration that kind of say, I have a group of pods, I want to emit them as one. I have an annotation called a WAS pod group, which is basically telling the pod group controller to create the queues pod controller to create a workload aware scheduling pod group. And that's what you can kind of see here on the right, sorry. You have 3 pod groups. It kind of knows the gang is 3. The thing that is what I'm realizing is that we would probably need more annotations kind of touching the different like disruption modes if we wanted to do this, but either way, I'm kind of walking before I run. And yeah, so I wanted to do a quick demo to kind of show all these things together and we'll hopefully leave time for a few questions. And I guess we have a very packed agenda, so I'll try and be quick. So yeah, so for job set, I have sorry, I realize I'm probably not sharing. Give me a second. Sorry, Amy. Do you mind if I finish the demo and then you can ask
No,
your
yeah,
question?
go ahead. Yeah.
Okay. All right. So yeah, do you all see a terminal?
Yeah.
Okay. So yeah, you can see this is a pretty small example. I just have a driver and a worker, a gang here. So if I go ahead and create the gang scheduling, you can kind of see the pod group. All the pod groups actually getting created, and you can tell that it is all the 5 pods are gang scheduled together, and you have a workload. Now, the thing that to keep in mind for those that are once you enable the workload aware scheduling APIs, Cube Control Get Workload will no longer get the queue workload. It will actually get the WAS workload. So we did make a change that interesting. Oh, it's because I don't have the queue enabled for this one. So yeah, this will actually point to the queues workload, and the workload aware scheduling one is actually Cube Control Get Workload. So just something to keep in mind. But yeah, so you can see the pod group is created. The job set, this is a fast one. So, and I don't have the topology awareness schedule, but this is kind of what my slides show already is like, you can have your driver and workers. And then the last one I wanted to show was kind of the queue pod group. Oh, okay. Yeah, so in this case, you can see I have a pod group sample, just 3 pod groups, and I want to create a WAS pod group. So this will go ahead and actually create the pod group. So you can see it's gang. One thing I actually realize I'm not doing is I'm not creating a WAS workload. I'll have to see if I actually need that, but either way, this works for gang scheduling. So you can see I have 3 pods that are created and the workload matches. And the idea, I wanted to make sure this was opt out also. So it respects the annotation so that if there's no annotation for what I've specified, it won't actually create the workload aware pod group. So yeah, and then I will go back to the demo real quick, and then we can go to some questions.
I guess the first person is Amy.
Yeah, please go ahead, Amy.
Yeah. I have a dumb question. So yeah, like I think this is Andrew also like linked the documentation where this is from. This is the implementation of like the original plan that was published. So it's queue workload creates a Kubernetes workload, then creates pod group. Is that correct? My dumb question is there a possibility for queue to ever directly create a Kubernetes workload? Probably not, right? Because we need all of the metadata for like the queue workload.
Oh, I think Mihal has thoughts on that one. I know
Okay.
that it could be that way. I think my concern, I basically like Q could create the workload, but I guess my only issue is Q doesn't create the pods of a workload, and I don't know if we want to kind of have Q responsible for creating the necessary components that I think like a workload controller should be owning and cleaning up, because there are there are some complexities around. For now, pod groups are considered immutable, but sometimes there's a question of like when a job is suspended, do I want the pod groups to be deleted, especially if they point to a resource claim? And I don't think Q wants to be in the business of like managing the life cycle of the pod groups for every workload, because I think that can get kind of cumbersome. But that's at least my thought, and that's also, generally Q is not used everywhere. So I think people need an integration point for at the workload level too. So yeah, that's at least my thought.
Gotcha. Mihao is next.
Yeah, so my first question would be similar. I think so. My question would be, how do you plan to choose which controller actually creates the workload for the Kubernetes workload? For example, how do we decide which level because currently Q has the Q name label, which decides at which level is the workload created, what is basically the unit of scheduling. And I know that we on production already have both patterns, for example, for job set. So some people consider job set like one big unit, and some people consider individual jobs as units of scheduling. So I'm wondering, I think Q doesn't want to get into business of where to create, but maybe at least choose the level so that the choice of the level, let's say if the user specifies Q name label at some certain level, then the same level is used consistently for the Kubernetes workload. Is this how it's going to work or some other way?
Yeah, that's a good question. For job set, I think it doesn't really matter too much because we know that it makes sense why you would do that. Like there are cases, especially from for me, the Kubeflow community has explicit cases where they want certain jobs to run first, and then other jobs run, so we can't have all or nothing gang scheduling for the entire job set. So in that case, you can have top level gang scheduling, but you can also have replicated job level scheduling. And I imagine for job set, there might be cases where each replica of a replicated job should be gang scheduled, but or kind of going to a certain node pool, which is kind of what I think we've seen in some cases. So at that level, I think job set would be fine. Uh, Now,
Yeah, but is there a way for Q to choose the level, for example, that because for Q, like it's the user that decided the level, right?
yeah,
So
I think
maybe
we
like
took the
question.
approach that the top level controller has to kind of orchestrate that. We can bring that use case. I don't know because like what we provide it at the job set level to control the job, but if you're saying I don't want job set to do any of this orchestration, but I want the job controller itself to do it, we'd have to actually see if we could support that because at the moment, right now we can't do it because at the like well, basically because we don't have the API for the job controller. But there is a way, like if the job spec has this the scheduling field, you could talk to the job controller to create the WAS workload or the pod group in the workload. But we did have a check to make sure that if a job is part of a job set, we'd want to disable the gang scheduling and stuff by default. So we'll have to see. That's one that because like I think by default we want the top level controller orchestrating the gang because they're the one doing the suspend. Like when a job set gets suspended, you want to kill all the pod groups and or you might want to delete those pods. So if we have the job itself doing it, it gets kind of complicated. So it's something I think we have to think about, especially once 1.37 lands. Because like yeah, like right now, what
Yeah,
I find is job set and job don't work well together with that because like job does create its own gang if it's an index job. And so that is a problem. So what I had to do is I have to disable the feature gate for job in order for job set to work with it because otherwise I have two separate pod groups that are getting created.
yeah. So that's why I was mentioned, like thinking about, like it only makes sense to create the workload at one level. The question is which level makes sense. So probably by default, as you say, the most sensible option is the top workload. At the same time, maybe some situations, if the top level is like app wrapper, then maybe not necessarily. Um, and also, if someone chooses in queue a little bit more of control, like not job set, but job, then maybe there are like cases where we would like to have API, maybe annotation or label that would indicate in the chain which level, at which level to create the work Kubernetes workload. That's what I'm thinking at least, because maybe always going to the very top is not the best. We this way we don't even know if the very top supports.
Yeah, no, that's a good point. Yeah,
So I just want to make sure to do time check. Let's go move to Andre and we can move the rest of this conversation offline.
I think mine is
Andre, you're
very quick.
next.
Yeah, so I think it looks good. I guess like on the designs, we can definitely follow up, Kevin, on the job set. I think I already make a point around maybe we should just say if the target replicated job is the empty, just empty list, we apply to the entire job set struct. I think we do the same for failure policies that allow us to actually have a higher level abstraction for the entire gang if you want to schedule it as a gang. But we can follow up on your cap if you don't mind.
yeah, no worries. I'm planning on giving this also on at 11. No wait, at 12 to the WAS group also, so we can talk more there.
Okay.
Also, I have a KEP update. I did update it. I did open up a KEP, so I imagine we can iterate on that one. We also can't merge this until 1.37 lands anyway, so we have time. Because I'm using the 1.37 APIs based off of main. So
Yeah,
yeah.
like the staging API, right? Okay, sounds good. Yep.
Yep, sounds good. All right, thanks everyone.
Thank you, Kevin. That was an awesome presentation. Let's go back to Andrea and Tara.
Hi, oh, sorry.
Oh no, you, Andre.
Okay. So this is just a continuation of the previous working group where we discussed adding the max priority threshold to reclaim within cohort. I think we discussed the Uber cluster queue and how that could possibly solve our issue, but upon further investigation, we realized it's only subtree scoped, so it wouldn't necessarily fit our problem that we've been facing. So in our issue, Sohan responded saying.
Are you able to share your screen?
Yes, I can do that. I think, oh, okay. So this is the issue. And we had some discussion here where Tara described our review of the Uber cluster queue proposal. So because we're working with a hierarchical cohort structure, borrowing and preempting across the different subtrees wouldn't be covered by the Uber cluster queue solution at the moment. So Sohan responded with basically because it doesn't cover that, extending borrow within cohort max priority threshold to reclaim within cohort config would be a possible path here. We just wanted to double check that with you all.
Can you also remind us of the original use case again, like the specific scheduling scenario?
Yeah, so basically we have a like parent cohort and various cohorts in the level below, and we want all of them to be able to have their own nominal quota and then a nominal quota at the parent level that everyone can kind of borrow from. And we also want to make sure that critical jobs don't get preempted no matter where they're scheduled. So if you borrow from a cohort at the same like subtree or tree level, if it's critical, it shouldn't be preempted, but if it isn't critical, it can be preempted if it's trying to use its own nominal quota. That makes sense.
And then, like there's whatever like organizational reason why you can't just give that cluster queue enough nominal quota, right?
Yeah, so we just want to make sure like all of the cohorts or cluster queues have if they have any idle GPUs, they can be used by other groups.
The thing with the Uber cluster queue was it's limiting in the way that you can't, because it can't do like the beyond the one subtree, you can't like have preference of who you take quota from first, which I think is kind of the main problem. So like if it's taking from all of them equally if somebody submits to it, but you can't say, hey, like this is the owning team for that job, so it's going to take from their quota first and then from other teams later. So if there was that type of feature, that would probably suit what we needed.
Mihao?
This still feels to me a little bit like Uber cluster queue. It's just that maybe I'm not sure I understand the limitation that blocks you, but if I am, well, what you want to do is to have a workload that is can preempt everything else, and nothing could preempt it. So this is basically like the objective of the Uber cluster queue. Maybe one thing, if I understand that is constraining to you, that you would like to have better control over the priority which cluster queues you take the quota from first. Is this what you want to discuss, limiting you on that, or something else?
Yeah, I think that's a limit. Like, I think basically not being able to choose who you take from, I think is kind of the problem, because we would want it to like prefer taking from stuff that's like owned by that team first, and then only bursting beyond that if it definitely needs stuff beyond that. So it should use up everything allocated to that work stream, and then beyond that, if it needs to.
But I think this could be maybe done by an extension to the Uber cluster queue by some kind of weights, so that when like basically we have Uber cluster queue. It has a pending workload. It needs to reduce quotas of some others. So then you have weights that, for example, take twice more from this one or 5 times more from this one, so that we would basically split, prioritizing first the or maybe like priority, like first exhaust quota in a subset of cluster queues, and only once you exhaust the quota from those, then only then go for the next ones. But it still seems to me within the um, potential scope of Uber cluster queue.
Yeah, I agree with I think when you describe like the weights wouldn't really work because it would be kind of different basically whoever originated whichever team the job belongs to should be the one that takes more of the hit. But that order that you're talking about, like the idea of like maybe having a way of like ordering per Uber cluster queue which it steals from first would actually probably suit the requirement.
Okay, and one more question. When you have the Uber workloads of this specific, would you be able to put them all into one cluster queue, or you, for some reason, need to have them mixed in every cluster queue? Like basically every cluster queue is entitled to be Uber at some point.
Do you mean like if we could just have one Uber cluster queue versus many?
Yes.
I think, well, it depends how it's implemented. It just needs a degree that we have to say, hey, if you're submitting under this team, you can take from this team's quota first and then beyond that. So if that means multiple Uber cluster queues, that could be a solution. Like in the way you're defining of like, oh, like you could define the order on the Uber cluster queue, then that would suit the use case. But I guess it depends how it's designed as long as that need is met. Like it doesn't have to be hierarchical. I think hierarchical is, I guess it could open a can of worms if you wanted to allow Uber cluster queues to be hierarchical. So like even though that's kind of what we had in mind, we're like okay not doing that if we could get the same behavior in a different form.
Yes. Okay, I understand your case. I think Marcin has some question, but just
Yeah.
it's not what we currently have, but point taken. I think it's a legitimate use case that we should probably cover.
Okay, so right now in the design, cluster queues are connected to some point in tree, right? And it was assumed that it will distribute the penalty of running workloads in cluster queue across the tree. So now you are suggesting that there is like one cluster queue that should be used first. What should happen after you take all of the quota from that specific cluster queue? How to distribute the pain across the others?
In our case, we probably don't care beyond that. But I don't know if others would have a use case where they.
So why does it make a difference there that it's critical to consume very specific cluster quota first, and then it doesn't matter?
Because it was
Sorry?
Oh, sorry, go on.
The thing with Uber Cluster Queue is that this is for very large workloads rather than having small. Because if you could feed the workloads into your own quota, or you could get it running with fair sharing, you could solve it either with like single cluster queues or by specifying fair sharing weight in large value to the specific cluster queue. So Uber cluster queue is to consume lots of quota that will cover not only the caller's cluster queue but everyone else. probably as well, like consuming 80%, 90% of quota in the cluster queue. Sorry, in the cohort tree.
That makes sense. That's not really like our use case. We were kind of pointed to Uber cluster queues as a solution for like.
So let me understand again. What's your very specific use case? Maybe I missed it.
So basically, we want to have like we have like a bunch of teams that like should each be able to own a certain quota, and then if the quota is not being used, then other teams can use that quota, right? But
Mhm.
if it is being if another team wants it and like so if a borrowing team or whatever you want to call it is using it and another team the owning team that owns the nominal quota wants it back, they should be able to take it back. But the way it's working right now is you can only allow any or lower priority to take back. So we don't want to use any because there are cases where stuff is so critical we don't want it to be evicted under any means. So even if it's borrowing, it should be able to remain. And so that's why the original request was for allowing max priority threshold on sharing within cohort. But like Uber cluster queues, if implemented in a certain way, could also fulfill our use case.
So your need is not for specific for Uber cluster queue. Your use case is for more fine-grained controls over who to preempt.
Yes.
Okay, because we are thinking about creating like a configurable preemption rules that will allow you exactly that, and that probably will cover Uber cluster queues and defrag. We don't have any specific cap yet, but it's work in progress. So hopefully we will have soon, and that should allow you to specify who you can preempt, in particular, limit reclamation to specific ranges, and also limit like the preemption range and do many other things. So from that, it seems that first of all, Uber cluster queues is not like the right tool for you. And the second thing is probably Uber cluster queue cap will not be merged as is, and it will be superseded by this generic preemption configuration mechanism, plus what Michał is about to present in a moment.
I think for their use case though, they have a non-preemptible workload, like even if it's borrowing. So like that's like the other aspect of why we suggested OpenQ originally.
Yes.
Like it's like a non-preemptible workload aspect. So it's like violating nominal quota. Yeah, these areas are all sort of like overlapping.
So the thing is that with Uber cluster queues, we are bending the rules for preemption. And the specific of Uber cluster queue, again, are not perfect for all of the use cases. So it probably means that we need to expose more knobs to get the behavior that the user truly needs. And that's why the current thinking is shifting from yet another enum in preemption mechanism to fully configurable with multiple knobs and switches. That we should allow you to express whatever is needed for you, and not like choosing between two solutions that neither fit your needs.
I feel like we're Tara, hopefully, I don't know if this is confusing, but it doesn't feel like we have like a good road forward other than kind of like keep engaging on like the GitHub issue and engaging with the Uber cluster queue, and then also march in the thing you're mentioning of like the preemption noms. Do Yeah, maybe we could take this offline because I want to make sure Marlo and Mihao and like Andrew are able to get in. But maybe we could discuss in the working group batch channel of like what Tara and Andrea can like specifically do to get unblocked.
That would be amazing.
Yeah. Marlo, you're next for the CNCF scheduling capabilities sweet paper.
Hey, I will turn on my video like I'm a human, so you have evidence, or I'm really good at deep fake either way. All right, so what I'm here to present is that part of the batch group over in the CNCF under the Workloads Foundation, which is a separate group, we have started looking at basically a scheduling capabilities suite. And I'm going to put a link in here and also a link to a Trello board. But if you would like to be involved, please let me know. The point of this is that there are many schedulers and it's hard to choose which one is appropriate for people's specific use cases. And also it's hard to measure, at least today, how a scheduler performs within a certain group of workloads. So if you have a particular group of workloads that you want to use for your particular cluster, what scheduler do you use? And it's very hard to tell at this point how to do that. So this is basically to help people make choices of what schedulers they use, but also make it possible to measure how a scheduler performs under certain groups of workloads. And this includes things like priority queues. So if you have a workload coming in the middle of a very busy cluster, how long does it take to launch that job? And all those things. So we're just getting started. Goal is to try to get at least the paper out by KubeCon. There is also a repo, but we're figuring out where that is going to go. So I'm not going to paste that here yet. We're going to put in some framework. The first target is, of course, Q, because that is the scheduler within Kubernetes proper as an organization. And then other people doing schedulers can then retrofit their scheduler to work with this framework. That is very fast, but we're close to out of time. Any questions? I was crystal clear and everyone understood me. Go ahead, Mikhail.
Yeah, you may, if I understand, part of the work is to compare schedulers and how they like create a framework that allows to compare them. Is it something like that?
Yeah.
So there is some prior work to that. You may check the work from IBM and Red Hat. I think at some point there was a KubeCon presentation in the past where a couple of schedulers were compared, Q including. I don't know which KubeCon that was, but I think if you ask on working group batch, some folks will be able to find it. So just
I can go look for it too. There's also one out by Alibaba. So there is some prior work that people have done, but not comprehensive across certain capabilities. And we're calling it a scheduling capabilities because it's beyond just speed of running a particular workload, because everyone has their benchmarks. This has to do with a group of workloads or, what are the parameters and tolerance for latency and all that. Andre?
Yeah, just a quick question. So I know that CNCF also we plan to publish the AI scheduling challenges white paper.
Yep.
How those two white papers will work together?
So the scheduling challenges is just all the things within Kubernetes that are challenging. So the very last page of that particular paper does have a table, but there's no real measurement going on. So we need a way to measure how a scheduler performs. So just because the scheduler says it has a particular capability, does it really? What is your latency time, etc. So if you can have a concept, for instance, of priority, but the latency of how long it takes for that workload to get started may vary according to your scheduler. So it gives the way to actually measure.
So I guess the goal is to kind of identify those main capabilities, right?
Yep.
Within schedulers. Okay.
Identify them, be able to measure them, because there may be cases where we are making assumptions that a particular type of optimization matters, but it doesn't. right? So it also makes it easier for the schedulers to figure out what they're targeting.
Cool. Andre, did you have any follow-up? Otherwise, we can move on to Mihal's.
I think I'm good. I guess the timeline, Marlo, you have like you plan to kind of publish it by KubeCon and A, right? As you said.
At least get the paper part in and the
Okay.
framework figured out, and then we can start doing actual measurements maybe by KubeCon EU. I usually use KubeCons as deadlines because otherwise stuff doesn't happen.
Conference-driven development.
Yes, absolutely. You know it.
Yeah, awesome. Yes, let's move to dynamic quota orchestration, Mihal.
Sure. Okay. Can I share my screen?
Yeah, let me
Oh.
see.
Give me a second. Okay, you can share your screen.
Right. So one problem that I'm trying to solve, or at least put some groundwork on alignment, how we solve the problem, is dynamic quota orchestration. So this has been solved already by some of our users. We know that they write scripts to basically adapt quotas in cluster queues depending on the amount of available capacity in the cluster, like nodes, because that fluctuates, and currently the quotas in queue are static. So in particular, this has been raised on multiple occasions, stuff like that. For example, we already have ongoing issue and the cap on automated aggregation of nodes. That was also raised on the Slack channel by the group that trained large-scale model, and that was one feedback from them was that it was annoyance that they had to adjust the quotas by themselves. The problem of hero workloads or Uber cluster queues, I think, can be attacked or fall naturally if we adjust quotas. I can talk a little bit more about this later, but basically what Uber cluster queues is they reduce the size of other nominal quotas to the level which allows to preempt the workloads by the Uber workloads. So it seems like a possible fit for the mechanism of also dynamic quota orchestration. It has also been raised that people have use cases for temporary quota overrides. So this again is something that currently needs to be done outside of queue. Another important use case that is actually initiated this on interest on our side is multi-queue. So basically, we want to have automation that allows to add or subtract new cluster from the pool of clusters, and then adjust the quota on the manager cluster accordingly without manually the admin adjusting the numbers. There is maybe also a case for DRA, because DRA devices can be reconfigured in different ways dynamically. So potentially changing the name of available quota we'll yet to decide if we cover this by the mechanism or not. This hasn't been discussed at length yet, but it seems to me that it could also be a natural fit for the work. So we have use cases for something like this from a couple of angles, and we could, of course, leave it to each and every individual contributor to solve the problem, but it seems that the overlap and the need for there is a need for overarching approach to these different problems. And if we try to solve them independently, we may end up with messy API. At least that's my main motivation. So the goal of this document is not to solve every single problem of every single feature, but rather to align the community on the approach, what we do and how we do more or less, we will figure out the details as we go along. So in this approach, I want to propose is a new CRD called Dynamic Quota Orchestrator. What it does, it specifies the route at which it orchestrates the quota. So this can be just simple cluster queue, meaning that it orchestrates the quota for one cluster queue, but it could also be a root of the subtree. So similarly as in Uber cluster queue, it can manage quota within a subtree that, so this could point to a cohort. Then we have some configuration to say which resources are managed dynamically. So maybe we have some dynamic flavors. Not every resource needs to be specified dynamically. Maybe this is what we will end up doing, but I want to have a little bit fine-grained control. So does this one. Because maybe, I don't know, licenses do not need to be managed dynamically, or they don't depend on anything that we have the dynamism for. So in this approach, I want to have two phases. The first phase is capacity discovery. So we need to know how much capacity we have. And here I think we have like three main sources of the capacity. One will be the multi-queue, local cluster, and then maybe also autoscaler. I don't put yet autoscaler. It's something I didn't have put much thought into yet, but I think it would naturally fit this model. And then the second phase, once we collect the capacity from different providers, it is to distribute. How do we distribute the quota? So you may imagine that, for example, admin puts some numbers for the quota like 200, 100, 100 for 3 teams, but the cluster shrank due to node failures, etc. So we want to, the most common use case is to compute how much quota we have. Maybe we no longer have 400, but now we have 300. So then we would like to dynamically decrease the quota for the teams. So we have some kind of rules for the distribution. By default, this could be just proportional to what was declared for the teams. So again, if this could be 2-1-1 proportion, but under some special features like Uber cluster queue, we could specify that this Uber cluster queue takes all that is needed, and then we decrease the others. Or we could this way also support the temporary overrides. If nothing is specified, I would assume this is the distribution is just proportional to what was declared by the admin. So then more details is provided, but we have 5 minutes for how to scrape the capacity. So this is kind of plugin architecture. So we will have a new CRD for scraping the capacity from nodes. So we imagine we will have some controller that will observe it will first of all read the flavors that we specify. Because maybe not every node, so we don't want to scrape the capacity from the entire cluster. We need to divide it into the flavors based on node selectors that are on the flavors, etc. So that's the configuration, and then it exposes what it scraped from the cluster into this standardized way in its status. Similarly, the multi-queue capacity, we will have a small controller for multi-queue where we put that this is the name of the cluster queue, and we scrape the capacity from workers that correspond to the cluster queue. So the orchestrator will aggregate capacity and distribute, and it will basically need to be able to override what is specified at the level of the cluster queue. So for this, I would like to introduce a new API field inside cluster queue that is like quota override tentatively. It will know where was the last update by the quota, who adjusted the quotas or overwritten them. So this could be the quota orchestrator and what are the new values. Yeah, so I posted some open questions that we have still during the discussions internal. So you may, first of all, I would like to ask, maybe there are some voices in the community. I think Yuki had some opinion that this should be in the status, but I had a lot of discussions already internally and thought about this. I think this probably should be spec because this determines what is the behavior, but it remains open. So I would welcome some discussion on that. There is also if we should scale the borrowing and lending limits. I think this can be done, but I don't again put it in the first proposal. But I think this can be done. It doesn't really change the design all that much, but maybe you have some thoughts here, how you would imagine scaling this and that. Yeah, and some maybe API question. We have last minute, so
Kevin, go ahead.
Welcome.
Yeah,
questions.
I guess the one thing, availability is actually a pretty hard, like restricted problem for the autoscaler. So I probably wouldn't, I would make sure to, because like in the WAS scheduling group, they were talking about there is a need for like basically getting inventory from a cloud provider, but that typically is proprietary and people don't really want to expose that information. So it might be worth like scoping out at least, is it possible to get like to probe an autoscaler to know like how much capacity I can actually do, because I worry this might be blocked from the autoscaling side. But I know at least that's kind of the one thing, yeah, I want to make sure we think about if we want to go this route, because I don't know if we can get this information from the autoscaler to know like how much we can scale.
Yeah, but even if we don't integrate with autoscaler, then we already have enough use cases to, I think about this generic API. So I don't consider this as a blocker, but yeah, we are thinking about autoscaler as well. It would be nice to be able to know how much capacity there is in, from autoscaler.
Sorry, I think we're at time. Andrew, is it a quick one? Like, is it a quick, like, one sentence answer type thing?
I don't know.
Ask it and I'll cut you off if it's not.
Okay, so this is related to automatic cluster queue quota limits. So the API that Michal showed, this interacts directly with it, but also invalidates parts of that CAPE as well. So how would the integration or how would the work in that CAPE go?
You mean how, like the other cap about the automation is still alpha? Yeah. I think that we may need to pivot a little bit. So for example, that one assume that the configuration is all inside the multi-queue config. I think we may need to move some knobs, but there are no knobs for now to the new CRD, like multi-queue capacity slides.
I think we're at time now. But I think if there's like a lot of follow-up conversations that can happen in the working group batch Slack channel. So if you all haven't joined already, please do. And then let's continue these conversations there. See you all in 2 weeks. Thank you.
Thanks.